Hello everyone, this is a Vissim video today, and in this episode I will explain how to use attribute modifications to model a school drop-off. It involves queuing around the red shoulder lanes, and it also involves changing routing, and we will use attribute modifications to do that. I made a previous video that I highly recommend to watch because this video builds on that. In that one I showed you how to use formula-based routing. And in this one, I show how to use attribute modifications to achieve the same. It's quite like a practice how to use different features in Vissim. And also it will help you to understand which one fits you better. I will do a third video, then I will show how to use Visvap to achieve the same. So just to have a quick recap. So there is a school here. Vehicles come on this route from the east, and we'll use this route to come from the west. When vehicle queue here along the red, they will drive through this shoulder, and when the queue reaches the end, when it reaches this detector, then they will drive down along this road, U-turn and wait in this shoulder. They will keep the always stop intersections clear, and I use priority rules. I explained those priority rules in the previous video, so if you're interested in that, check that out. In this one, I will talk about the attribute modification only. So let's have a look. In the previous one, in the formula-based routing, I used partial vehicle routes, and the route choice method was formula-based. So basically, we checked occupancy on this detector, and when it was more than 3 seconds, then we rerouted vehicles down here. The reason it was 3 seconds, that avoids if a vehicle U-turns here, drives over the detector, and as it drives over, the occupancy will go up to like 1 or maybe 2 seconds, and that could trigger a reroute. We don't want that. Okay. So in this one, what we do, we use static, and we use attribute modifications to change the relative flow of those partial routes. Those partial routes are basically, let me just show you. So we have static routes for background traffic, and we have static routes for school traffic. Background traffic and school traffic are in different vehicle types and vehicle classes. You can see that there too. 10, 10, 70, 70. 10 is background, 70 is school. So this is the static route from the east, and that is the static route from the west. I have partial routes that overrides basically this part, and they will add a loop through there, and from the north it will add a loop through there. And these, so if I go back to the partial, these relative flows will be set using attribute mods. So with attribute modifications, it is very important that we update the actual data there. So if you run your model, you finish it with a certain relative flow, and if you save it, that will be the way you pick it up next time. So the model can have wrong relative flow when you start. So it is very important that you initialize it. That's why I have two attribute mod that runs before simulation start, and the object type is partial vehicle routes, not partial vehicle routing decisions, partial vehicle routes. Partial vehicle route is on the right, partial vehicle routing decision is on the left. So that little line is the decision, and those light blue ones are the routes. We have one decision, And for one decision, we have two roots. And we change the root, not the decision. We have two, one from the east, one from the west. That's why here we use an object filter. Here it's 2. Here it's 1. Because this attribute mode only updates the first, the other one updates the second. The target attribute is the same for both. It's relative flow 0 to max. You just select it. And make sure that before simulation starts, as you can see, we put 1 here because I think I maybe said it wrong before, but this is the number there. That is the number. So root 1, root 2, because this is also 1, 2. So in the attribute modification here, this object filter number 2 is the root and not the decision. Sorry if I said it wrong a second ago. So we update this and that. So number 1 and number 2. So again, this attribute mode filter here, number 2, is showing or pointing or referring to number that and number that, not to number that and number that. So one attribute mode updates basically for all partial vehicle decisions the second root. So it is important that for each partial root, the second one is the long. The second one is the long. So when this runs, for all long ones, it puts 2. So we start with zeros for the long ones, and we start ones for the short ones, the number ones. These. So if I select both, so that and that, yeah, and we put 1 for these, you can see relative flow. So it will update it as I start the model. So it as I said before, if you saved your model from previous run, it remembers the wrong one. So let me just run the model. So let me highlight the long ones. If I just start it, you can see now it has been updated both. So now the short ones have 1 there. Because this and that run before simulation start. Okay, so no, initialization is initial. I can't pronounce it. So that thing is done. So now we have the right root choice to start with. So now when vehicles arrive, they will use the short one. So they will get into this shoulder and not to there. We also need now 2 attribute modifications. Again, 1 for each, the short ones, and 1 for the long ones. This will run at every time step. It doesn't matter too much if you run it at the start or end. And basically, we just copy paste the same table lookup from the previous model to formula-based routing. We check. We have a table lookup where we look for detectors. So we have detectors. All of the detectors have port number 1. Because if detectors share the same port number, they will share basically the attributes as well, like occupancy, for example. So if one detector is occupied, all of them will be occupied. But they will be treated like as one big detector instead of 10 separate ones. So we look for port number 1 detectors. And this third section is the result that will be put here into this target attribute. So relative flow will be updated with the number that this results. Here I have an if, and I will put into the description the video where I go into more detail how to use table lookup. So in here, what I do is I check the occupancy on the detector it returned. So this condition, we get the detector, and that detector has, if the detector has an occupancy more than 3 seconds, then I will put 0. If it doesn't have an occupancy more than 3 seconds, then I put 1. Since this is the object filter number 1, so the partial routes first route, so the short route, will be 0 if the occupancy is more than 3. So that means there is the queue has reached the end of the queue on this detector there, or already vehicles driving or waiting along this long detour. That way, I will keep this route 0 and I will assign, otherwise it will be 1. So 0 if the occupancy is more than 3 seconds, or if that's not true, then 1. So 1 will go into there. And the other one is for object number 2. So this is for the long route. And here is the same stuff. This whole is the same. The only difference is are these two numbers. It just swapped around. So if we have an occupancy more than 3 seconds, we put 1 into relative flow here. So that means we switch on, we turn on this long detour route. Or if there is no occupancy, we put it 0. That means vehicles should be using the short one. I hope it wasn't too much. If you struggle with this table lookup, please check out the video for the table lookup. And I recommend to check the formula-based routing, because in that one I go into more detail of the priority rule and some more details of detectors as well, why to use port number and so on. Thank you very much for watching. And if you subscribed or like my videos, I really appreciate it. And if you decide to support me more, you can do that by signing up on YouTube as a member, paying member, or on Patreon as a paying member. Thank you very much for watching, and see you in the next one.